Hello, everyone. Today, we'll be discussing how you can use Amazon Forecast to build an inventory planning solution. I am Namita Das. I lead product development for Amazon Forecast, which brings machine learning capabilities into the hands of developers without requiring any machine learning skills. With me today, I have Supratim Banerjee, Chief Transformation Officer at More Retail, one of the largest grocery store retailers in India. For today's discussion, I'll start by briefly reviewing the history of forecasting at Amazon.com and then providing an overview of Amazon Forecast. I'll then lay out key steps that you can follow to be successful when building your inventory planning solution. And I'll also walk you through the console on how you can use Amazon Forecast. Then Supratim will walk us through how his team used Amazon Forecast and was able to reduce inventory waste by 30%. And in the end, I'll end with some key resources for you to look at to get started. Now, forecasting is the science of predicting the future with historic demand. Amazon is a global company. It ships billions of products each day across 185 countries. Forecasting is used not only to meet customer demand, but also to optimize their supply chain to keep costs low. Now, forecasting is critical at Amazon because we are able to make 400 million unique items available to customers immediately at low cost. We've been investing in forecasting from a long time. But if you see, in 2007, we started using machine learning in forecasting, and it was mostly used for some complex situations like new product introductions or disaggregating national and regional demand, or even for forecasting highly seasonal items that are driven by pop culture. In 2015, we introduced deep learning models where we saw a step change in our accuracy because now we were able to learn from those nuances between products and across time. So Amazon.com has been very successful using forecasting. And what Amazon Forecast does is it takes this experience of Amazon.com and it bundles it up into a fully managed service called Amazon Forecast, which provides machine learning capabilities to developers who don't need to know any machine learning at all. Amazon Forecast provides more accurate forecast, up to 50% more accurate than traditional systems. So now if you look at this diagram, you will see that you can provide your historic demand data to Amazon Forecast, and it does the rest. It will create the data pipeline to ingest the data, and then train a model, provide accuracy metrics, and create forecast. But in the background, it's doing much more. It's identifying features from your data set and applying the best algorithm that suits your data type and tunes those forecasting models. And then it hosts that model so that when you want to forecast, you can easily query the service. It also cleans up the resources that are no longer needed. Now, many customers are using Amazon Forecast to directly use for their forecasting needs. But there are also other customers who are using Forecast to build ML capabilities into larger solutions. For example, Anaplan, a cloud enterprise planning platform, uses Amazon Forecast and has created a new product called Plan IQ with Amazon Forecast. And this intelligence framework combines the capabilities of Anaplan, its large scale and scenario modeling capabilities, with AWS AI capabilities and forecasting capabilities, so that advanced analytics is easily available to business users. Now that I've given you an overview of what Amazon Forecast is, I'm going to walk you through some key steps that you can use for building your inventory planning system. Now, customers who are successful use Amazon Forecast in 4 ways. They follow these 4 steps. The first is to identify your business objective and identify the business use case. The second is to identify data sets that are needed for those business use cases. The third is that when you train and optimize your model, that they look at accuracy and they tie back that accuracy to the business use case. And then lastly, it's about deployment. As soon as customers see an accuracy improvement or a positive impact to business metrics, customers deploy Amazon Forecast, while on the side, they may continue to test and optimize their models. Step 2, 3, and 4 are something that I'm going to show you through the console, but for now, let's talk about step 1. Step 1 is the most important step because this is going to guide you through your forecasting process and how you will be evaluating your accuracy and your models. So start by identifying what is the priority for your business. For some customers, it is increasing revenue, and for other customers, it is decreasing costs. So identify your business priorities and the SKUs or the items that drive those business priorities. And then for those SKUs and items, evaluate your current forecasting methodology and understand what the baseline accuracy is. For customers who do not have existing forecasting tools, a good proxy of your baseline would be to look at your current demand deviation to your product ordering system, or maybe your finance team is creating projections, so looking at your current demand versus that will give you a good proxy baseline. And lastly, think about what change can you do when you do see an increase in accuracy. How will that impact your business? What action you're going to take? How much is it worth? And really answering that question will help you understand what is your forecasting use case and what you are forecasting for. Now, step 2 is identifying your data set. A lot of customers want to bring data for their forecasting, and those data is stored in different databases. For example, historic sales data is stored in ERP, whereas price and promotion data might be spread across multiple spreadsheets. So start by identifying those data sets, and even if you want to integrate data sets like third-party data sets like macroeconomic parameters or metrics that might not be in your system and maybe in a completely different time format or data format. Then a lot of customers ask us, how much data should I bring? And my guidance and our guidance to this is that once you have identified the SKUs that are important for your business, take as many items as SKUs from that when you are coming to forecast, because you want machine learning models to learn from that data. And if you're forecasting at a daily frequency, and historic data from the last 2 to 3 years should be sufficient. So once you've identified all the data that you need, you can now go through the steps of aggregating the data and collating the data into a unifying time format so that you can import that to Amazon Forecast. So once you go to the AWS console and you search for Amazon Forecast, you will land on this particular homepage. Here you can go click on the Create Dataset group to start a forecasting project. A dataset group is a collection of datasets that's applicable for your use case and forecasting problem. Once you've gone through and filled out your dataset group details, you will land on this dashboard that walks you through the process of importing your dataset, training your predictor, and creating your forecast. And these are steps 2, 3, and 4 that I'm outlining today in my presentation. So right now we are at step 2, that is importing your dataset. And once you have aggregated, collated your data, you will upload it to your S3 bucket into 3 distinct files. The target time series is the mandatory data file, and this is where your historic demand is stored, and this is the variable that you are predicting into the future. A typical schema would look like timestamp, item ID, and target value. And I'm pleased to announce that today we are launching the capability for you to also add geolocation information to your data so that you can use geolocation for your different stores and create geolocation level or store level forecast. Now, item metadata and related time series are optional data set. These are data sets that you can use to increase your accuracy. And sometimes they do lend more statistical power to your demand forecast. Item metadata is static in nature. It does not vary with time, and it is qualifying the items. So typical examples would be if you want to add brand or category of your product, or if you want to qualify an item like the color of it, an attribute, or even if you want a binary variable like whether a TV is smart or not. Many examples of related time series would be price or promotion, or even third-party data sets like local events. Here I'm going to walk you through how you can import the target time series. A similar experience is also there for item metadata and related time series. So when you come to this page for adding your target time series, you will first define your schema. And you can use the schema builder to easily drag and drop your different schema columns and specify the timestamp format and even the location format. Continuing down, you can then specify more time zone information and IAM permissions and your S3 files, S3 location as well. Now, many customers have told us that cleaning data takes a long time and it's very challenging. And data is messy, and especially finding those missing values can take a long time. So we do provide automatic filling options that you can use. So for example, you can fill it with a 0, NaN, which is very useful for calling out an item that is in stockout, or with a median and maximum value to fill those missing values. So coming to the next step, this is step 3 in our presentation today, is around training your model and optimizing the accuracy for that. So you can click on Start Training, and it'll take you to this page where you will first tell us what is the forecast horizon, or how much in the future you want to forecast and at what frequency. So an example would be that you want to forecast for 3 days out at a daily frequency. And we need this to be able to tune your forecasting model so that it is tuned for your particular use case. You can also specify forecast types. After this, you can specify the algorithm selection process. And to train a model, you have 2 options. One is AutoML. AutoML finds the best algorithm and model for your data set. And we recommend using that because different algorithms are useful and have strengths for different type of data sets. So for example, an algorithm that is best suited for sparse data sets might be different for one that is used for consistent demand. And when you use AutoML, we find the best algorithm for your data needs. Now, if you are an advanced user and you understand the algorithms that are powering Amazon Forecast, you can also select to manually choose an algorithm. And we provide 2 different types of algorithms. One are statistical traditional methods, and the other are machine learning. So traditional statistical methods are called local models. And they are best used when you are forecasting for a handful of time series that don't have patterns across each other, or you are forecasting for simpler use cases or simpler seasonal patterns. And the reason I say they're local models is because they create a model per time series. And those models don't learn from each other. But machine learning algorithms learn across item metadata, related time series, and your time series. They learn across all your different items and SKUs, and they create one model. And that's why global models are more powerful when you have a lot of data. They're able to pick up those nuances that might not be that intuitive to you. Now, customers tell us that they want to add third-party data sets to improve their forecasting accuracy. And one of the top asks of retailers is that they want to account for weather conditions. And we know that short day-to-day changes in weather will impact short-term demand for those products at those particular location formats. So I'm very excited to announce that we are launching today the Amazon Forecast Weather Index that helps you increase the accuracy for those items that are impacted by weather. And so we add local day-to-day changes of weather to your forecasting model with only 1 click and at no extra cost. The Amazon Forecast Weather Index is made up of many different weather metrics and is right now available for US and Europe locations, and will soon be available in other regions as well. For customers who are interested in adding holidays to their forecasting model, they can continue to use the holiday feature and add national holidays to up to 66 countries. The Amazon Forecast provides you flexibility in experimentation and optimizing your forecasting model. So when you add your training data to Amazon Forecast, it automatically splits that data into a training set and a testing set. It trains the data on the training set and uses the testing set to create accuracy metrics. So you don't have to hold out a separate set of data to measure the accuracy by yourself. Many retailers tell us that for them, some SKUs or subset of SKUs are more important than others. For example, 80% of the revenue is driven by 20% of the SKUs. And these customers are looking to understand how a forecasting model is performing against those top 20 SKUs. Now, Amazon Forecast provides accuracy measurements at an item level, so you can see how the forecasting model is performing against those important SKUs. And I'd mentioned forecast types earlier, and forecast types helps you optimize for under and over forecasting cost. Traditional methods of forecasting provide an average mean forecast. Whereas in Amazon Forecast, not only do we provide the average mean forecast, but we also provide a distribution of forecast so that you can capture the demand variability and create forecasts at different distribution points. These distribution points are also called quantiles. So retailers may select different distribution points depending on their risk appetite or depending on whether they are struggling with over forecasting or under forecasting and where their costs lie. Now let's take an example. So imagine you're a grocery retailer and you want to over forecast. Let's take an example like milk, and you want to be able to store extra milk to be able to meet demand. And so for such a customer, a quantile like 0.9 or 90% would be better, because what they're saying is that 90% of the times I want to meet demand. And so 90% of the times the demand would be either equal to the forecasted value or less than. Now we come to our last step, and that is generating forecast. When you go to the generating forecast console page, you can just enter the forecasting model that you've selected and that you've optimized and you want to select and create your forecast. I've just walked you through how you can use the console to use Amazon Forecast, but you can do the same to use the service through the APIs to automate your system and integrate with either your ERP system or other in-house system by using other AWS services. And lastly, what we see is that customers who are successful, they either immediately deploy Amazon Forecast as soon as they see an increase in accuracy, while on the side they may continue to experiment more and improve their accuracy, or they have Amazon Forecast running in shadow mode in parallel to their existing forecast system while they're optimizing their supply chain processes. And when those processes are built in place to accommodate for newer machine learning process, they then switch to Amazon Forecast completely. With this, I would now like to invite Supratim Banerjee, Chief Transformation Officer at More Retail, one of the largest grocery retailers in India. And Supratim is tasked with modernizing and digitalization of the supply chain at More. Here you go, Supratim.
Thank you, Namita. I'll quickly introduce myself. My name is Supratim Banerjee. I'm the Chief Transformation Officer of More Retail. I'll talk you through our journey of using Amazon Forecast to deliver business value as part of the wider transformation that we're trying to do at More Retail. A quick background of More as a company. We do about $1 billion of revenue. We are one of India's largest food and grocery retailers. In fact, we are one of the fastest growing as well in India. We have a very wide network spread across most parts of India with about 600 plus large and small format stores. We have a very wide supply chain spanning 13 distribution centers, 7 fruits and vegetables collection centers, and about 6 staples processing centers across the country. For us, it's extremely critical to deliver the right product quality at the right economic value for us as a retailer for the fruits and vegetables category. And this is where we worked very closely with Amazon Forecast to achieve both these objectives. To start with, the problem that we picked was to forecast demand for the fresh category. And this inherently has some critical challenges or complexities that we had to deal with. The first part is that the product is inherently a low shelf life product. It's a 2 to 3 day shelf life product. Therefore, the margin for error as far as forecasting is concerned is very, very small. If we land up under forecasting, we'll end up going out of stock, and that spoils the customer experience. If we land up over forecasting, we either present poor quality or stale stock to customers, or we have to throw the product away, and therefore there's wastage. And with this problem, we had to get our demand forecast, absolutely right to make sure that we optimize the customer experience as well as not having to waste product. The second problem that we had was that we were trying to solve this problem across about 100+ SKUs over a network of about 600+ stores, and that added complexity to the problem. And as I mentioned, the big factor for us was uh, the moment we throw product away because it's past its shelf life, it immediately impacts the profitability of the category. So this was the complexity that we were dealing with at More. Before I talk you through the journey of how we got here, I just want to talk about the results that we got using Amazon Forecast. The first thing that was very interesting for us is that we improved our demand forecasting accuracy from about 24% to close to 70%. By doing this, we reduced the wastage by up to 30%. While reducing wastage, we managed to improve our in stock or product availability from 80 to 90%. And through this journey, we managed to finally deliver a 25% bump in profitability for the category. So this sort of ticked off all the boxes for us where we took an AI ML based solution and delivered business value in a real world retail situation. To us, this was a problem that we went through a fairly interesting journey, right? And we finally, when we landed up exploring Amazon Forecast in detail, we realized the benefits of using a machine learning based approach to demand forecasting. On the left hand side, I've just tried to articulate what we did as far as our initial approach was concerned. So, our initial approach, we took every store SKU combination and tried to build a model for each of them. So as a result, we landed up having close to 1,000+ individual time series models. And we experimented with Arima, we experimented with Profit, we experimented with Winters. And they did give us a lift in accuracy, but we were probably in the 40-50% accuracy range. We finally landed on an ML based approach for demand forecasting for a couple of reasons. The first was we built two large national models for the different categories. This dramatically improved accuracy for us. It actually outperformed all the other individual 1,000 models and an ensemble of these. And we were able to build a very rich set of related time series as well as metadata to improve accuracy. To me, this was the sort of key feature that attracted us as far as Amazon Forecast was concerned. In any grocery buying experience, customers buy in a shopping basket, and there are signals from the purchase of one product or demand of one product with another product. And what a product like Amazon Forecast does using machine learning is take all this information to arrive at each of the individual time series forecasts. So this was a very interesting approach that we eventually landed on while we started with trying to forecast each time series and build an ensemble. And my own belief is that's what helped us improve accuracy. The other thing is by being able to enrich the data set with metadata, we were able to also provide business context to the model. So, for example, we were able to categorize products in terms of their shelf life, in terms of their price per unit, in terms of whether we're running promotions on them. Similarly, we were able to provide metadata information around the type of stores where we're running this model. So, is it a store in a very affluent cluster? Is it a store in a very competitive segment? Is it a large store? Is it a small store? So all that metadata also help improve accuracy quite meaningfully. We took a bunch of very critical decisions, right, to maximize business impact. And I'll just walk you through the steps of what we did to achieve this. To start with, on the left, we focused our experimentation on a segment of the problem where we would get the maximum bang for the buck. So the chart on the left, the x-axis plots ABC, which talks about the dollars of shrink or wastage, so the materiality of the problem that we were trying to solve. And on the y-axis, it plots XYZ, which talks about demand variability. We focused a large part of our energy in trying to tackle material uh, drivers of shrink, but for highly variable demand categories because that's the hardest one to forecast. We also built, as I said, a global model. So we put in all the variables into a global model where there were close to 6,000 plus store SKU combinations, right? And each time series could learn from the experience of the other time series at that point in time across geographies, across product categories, right? And the last part, which was very important for us, is we were perpetually trying to optimize the output by trying to balance the cost of shrink or wastage with the cost of stock out or lost sales. And we use the quintiles of the results of the forecasting algorithm to move the forecast response right from the model. The last one, in fact, in production, the way we've done this is we've actually automated the flow. So the output of Amazon forecast, if a product is stocking out, then automatically our production system starts taking higher and higher quintiles of forecast. If a product has high wastage or high shrink, the model automatically takes lower and lower quintiles of Amazon forecast. By being able to work inside this zone of probability, we're able to fine tune the trade off that we need to make at all points in time between in stock availability and wastage. I'll also walk you through the overall deployment architecture. We had taken a decision early in the year to migrate all our systems to AWS. And in fact, that's a journey that we're undergoing even as we speak. But one of the benefits that we had of using Amazon Forecast was it was very tightly coupled with the entire AWS ecosystem in which all our systems run. Right. So I'll just quickly walk you through each step of the architecture that we deployed in production. So to start with, all our transactional information is backed up in a Redshift data warehouse, right? After that, we have a bunch of custom Python scripts in EC2, which wrangle the raw transactional information as well as metadata information, pass it through S3 objects into the Amazon Deep AR Plus forecasting system. This entire flow is automated through Apache Airflow. So this happens at a particular time of day, depending on when the business processes are triggered. And finally, when the forecast is generated, the results are dumped into a S3 object. The upper part of this chart, therefore, talks about the exercise of forecasting. The lower part is actually as critical in this entire journey, which is to convert a forecast into an indent or an order that we place on our suppliers to supply products. So it starts with all other indent parameters that we go back into a Redshift data warehouse. For instance, what's the stock on hand at a particular store, right? What's the shelf life? What's the in-transit quantity? These are some of the variables that we first look up. We then pull the forecast, which is the forward-looking demand forecast, with all these other parameters like stock, shelf life, etc., and pull together an indent. This indent is then pushed into our ERP system, which is an Oracle ERP system, and that in turn then gets the ERP takes over and places an order on the supplier. All these results are then backed up again into Redshift, and this loop then gets closed. For the sake of managing the entire production ecosystem, we have through Apache Airflow email notifications that we've deployed across this to make sure that there is fidelity across the process. And if anything breaks, our production team can step in and intervene and make sure that they follow up with the store to make sure that they close out a process, whether it's to record inventory, record receipt of stock, or check with whether the batch data transfer from the transaction systems have moved to Redshift. This architecture delivers the benefit of Amazon Forecast to us because it is tightly integrated in AWS. It is also tightly integrated with our ERP. So this is a hands off the wheel system which is automatically converting demand into a forecast and a forecast into an order without any human intervention. To step back as we reflect on our journey, I think there are three very critical aspects of our success. The first part is the ability to experiment. Because the Amazon Forecast platform is reasonably flexible, right, and modular, we ran probably close to 200 experiments, right, with different regressors, different types of models, the machine learning model, even some of the more sort of traditional models like Arima, just to have the full satisfaction that the solution that we finally landed on has been thoroughly tested. The second piece is because we are integrated into the AWS system, we were able to immediately integrate a good forecasting system and convert it into an indenting or an ordering system and build an automated ordering system without much trouble. And the third piece was these are systems that are perpetually iterating. At any given point in time, we think of new features to improve the forecast. We think of new features to improve the indenting system. So that's the first box. The second box is we worked very closely with a partner of ours called Ganit. They're a data science team. More Retail, Ganit, and AWS formed a lethal combination as far as solving this problem was concerned. And therefore, in our minds, partnering effectively as part of this solution was key. And of course, the third piece is change management. In any journey of this nature where you move to an automated indenting system, there are teams who are used to placing orders. There were category teams who were used to using their business judgment to order products. We are essentially asking them to trust a machine learning based system. So we have to take our teams through this journey and get them to adopt this tool. We had to also get our store teams and our supply chain teams to operate with a certain amount of discipline so that the indent that's generated is filled, stock gets recorded properly on time so that the entire architecture works in a seamless manner. Thank you very much. I'd like to hand over back to Namita.
Thank you, Supratim, for walking us through how your team was able to achieve a 30% reduction in waste by using Amazon Forecast. So to end, Amazon Forecast is a machine learning capability that takes in history, the forecasting history of Amazon, providing you in a fully managed service to developers who don't need to know any machine learning at all. To get started, I recommend going through some of our resources and also go through our notebooks, which will take you through a step-by-step process of using the API. And we also have a plethora of partners who can help you get started in executing a POC and also integrating with your in-house systems. Lastly, AWS provides a choice for you in using machine learning for forecasting. Thank you for tuning in, and please fill out the survey.